Look at the map of North America right now. It looks less like a weather forecast and more like a continent actively tearing itself apart. In the upper Midwest, the rivers are simply running out of room. Relentless, heavy rainfall from successive early April storms has completely saturated the regional watersheds. The Baraboo River in Wisconsin is currently experiencing moderate flooding, pushing relentlessly toward a forecast crest of 18.1 feet. That is a dangerous volume of water, but the crisis does not stop in Wisconsin. Further south and east, the vast Ohio River basin is swelling dramatically. Water is inundating low-lying roads and agricultural plains across Indiana, Ohio, and Iowa. Multiple flood warnings remain active as the Ohio River crests at moderate elevated stages. You would look at this picture and assume a sprawling, relentless wet pattern has completely hijacked the continental weather system. You would be entirely wrong. Look out west. Look at the deep south. While the Midwest drowns, the chaparral is burning. In Riverside County, California, the wind-driven Springs fire has ripped through over 4,100 acres of drought-stressed fuels. Evacuations were ordered earlier this week. Containment lines are being severely tested by deeply uncooperative bone-dry conditions. Moving east into the plains and down into the southeast, the air is aggressively dry. High winds and dangerously low humidity have triggered elevated fire weather warnings across multiple states. State forestry officials in North Carolina are urging extreme caution as the ignition risk skyrockets in forested areas. Orange County, Florida has enacted strict burn bans, driven by drought indices that are spiking off the charts, requiring a full 7 days of significant moisture just to reset the danger. Floodwaters in the north, fast-moving flames in the south and west. It is an impossible split screen. But that is just the surface. Between these two intense extremes, the atmosphere is violently tearing at the seams. Strong to severe storms are ripping across the Mid-South. A sweeping cold front is packing dangerous wind gusts capable of exceeding 58 miles per hour, dropping 1 to 2 quick inches of rain and prompting severe storm alerts. Metro Detroit just took a brutal beating from high winds and blinding rain. The storms downed towering trees, knocked out power grids, and even triggered a brief tornado warning. Farther out, isolated thunderstorms are popping up from Florida all the way to the southwest and even up into Oregon. And yet, straight through the middle of this chaos, Salt Lake City is plunging into late-season freezing temperatures. Thermometers are briefly dipping below 32 degrees Fahrenheit, threatening early spring blooms and vulnerable agriculture. Cold snaps, windstorms, drought, floods, fires. It looks entirely random. It feels like a localized breakdown of typical spring weather across completely disconnected regions. It is not random. It is highly, beautifully, and terrifyingly organized. Every single one of these seemingly disconnected disasters is being driven by the exact same atmospheric machine. We are tracking a single, massive spring circulation pattern, locking into place over North America. I call it the split jet engine. The split jet engine is a continent-spanning beast of a system. It is the sole recurring suspect behind this chaotic, violent map. The 18.1-foot floodwaters in Wisconsin, the split jet engine, the 4,100-acre burn scar in Southern California, the split jet engine, the freezing drop in Utah and the severe storm alerts tearing through Memphis and Detroit. All of it tracks back to this exact same wave. It is a single, locked-in mechanism spinning above our heads. Here is where it gets stranger. We are accustomed to massive storm systems that bring widespread rain, or dominant high-pressure ridges that bring continental heat. But the split jet engine is doing both at once. It is perfectly balancing absolute atmospheric opposites. It is pushing rivers well past moderate flood stages in one zip code, while desiccating brush down to absolute kindling in another. And it is holding this exact pose, day after day, refusing to break form. How does a single spring circulation pattern build the momentum to flood the Ohio River Valley, while simultaneously throwing a freeze over the Great Basin and fanning flames across the southwest? How can one atmospheric engine produce deep floods, explosive fire, severe thunderstorms, and a rapid deep freeze all at the exact same time? To understand exactly how this is happening, you have to look at the upper atmosphere. The data line up perfectly when you trace the high-altitude winds. We are looking at repeated storm tracks carving a deep permanent groove across the continent. From April 2nd through April 5th, the northern branch of the split jet engine locked itself over the exact same geographic corridor. It became a high-speed atmospheric conveyor belt. It relentlessly dumped massive amounts of rainfall directly into the Ohio Valley and the upper Midwest. The ground simply could not absorb any more water. The regional watersheds became entirely saturated. That is why the rivers are failing to drain. It is why the Baraboo River is surging toward a crest of 18.1 feet. It is why the sprawling Ohio River continues to crest at moderate elevated stages days after the actual rain has stopped falling. The split jet engine is functioning like an open fire hydrant, funneling Pacific and Gulf moisture straight into the heart of the Midwest. But that water has a physical cost. Downstream of that intense flooding, the atmosphere is forced to balance the immense energy being generated. As the core of the split jet engine pushes these heavy, rain-wrapped low-pressure systems eastward, it drags a powerful cold front right behind them. This cold front forcing creates a highly volatile boundary line. It violently wedges under the warm, humid spring air sitting over the eastern half of the country. This violent lifting mechanism supports the sudden, strong, severe storms erupting in the Mid-South. It is the exact same aerodynamic forcing that generated the damaging wind and heavy rain impacts around Metro Detroit, strong enough to trigger power outages, down trees, and prompt a brief tornado warning. The split jet engine is acting as a massive wedge, ripping the lower atmosphere upward and translating high-altitude wind energy directly into ground-level severe weather. And that brings us to the most dangerous contradiction of all. Look at the dry side of the circulation. While the northern branch of the split jet engine lifts air to create violent storms and relentless rain, the southern branch does the exact opposite. On the backside of this massive atmospheric wave, the air is rapidly sinking. In meteorology, sinking air is called subsidence. When air sinks from the upper atmosphere down toward the surface, it compresses. As it compresses, it dramatically warms and dries out. It literally bakes the ambient moisture out of the environment. This immense zone of subsiding air is blanketing the southern half of the United States. It is forcefully pushing humidity levels down to critical single-digit thresholds. Combine that ultra-dry air with the gusty pressure gradient spinning off the massive storms to the north, and you have a continental-scale blowtorch. This is the exact mechanism driving the aggressive fire weather. It explains why the chaparral in Riverside County is burning so intensely, turning over 4,100 acres to ash in a matter of days. It is why the deeply dry, windy conditions have forced forestry officials in North Carolina to issue heightened statewide wildfire risk alerts. It is the physical reason burn bans are being strictly enforced across the plains and down into Orange County, Florida. The split jet engine is physically robbing the southern latitudes of moisture, pulling it north to feed the Midwestern floods, and leaving behind an absolute tinderbox. The entire picture suddenly makes perfect aerodynamic sense. It is a closed-loop system. The wet side drowns, the dry side burns, the boundary line spawns severe thunderstorms. It is a beautifully brutal display of planetary physics. But if the split jet engine perfectly explains the flooded Midwest, the severe storms in Detroit, and the burning chaparral in the southwest, we are left with a glaring, highly localized problem on the western edge of the map. Look closely at the Pacific Northwest and the Great Basin. Why does Washington state suddenly show minor flooding on the remote Stehekin River? And why, right beneath that very same system, is Utah abruptly dropping below freezing? If this one dominant engine is running hot and dry in the west, how is it simultaneously pulling enough Pacific moisture into the Cascades to push glacial-fed rivers past their flood thresholds, while freezing the ground in Salt Lake City? This is where the split jet engine gets sharper. Its northern branch is doing something deeply counterintuitive. As this immense upper-level wave carves its path, it plunges deep into the intermountain west. It drags massive pools of cold air directly south. This is exactly what is driving that sudden, anomalous cold snap. Salt Lake City is seeing temperatures briefly drop below 32 degrees Fahrenheit. It is a late-season freeze threatening early spring blooms and vulnerable agriculture right in the middle of April. But just a few hundred miles away, that exact same northern branch of the split jet engine is sweeping up off the Pacific Ocean. It is slamming a pipeline of moisture directly into the high elevations of the Cascades. The Stehekin River in Washington is reacting immediately. Recent rain combined with rapid spring snowmelt is nudging the glacial-fed river into minor flood stages. The anomaly is easier to spot now because officials recently revised the minor flood stage thresholds lower after massive December events, drastically improving early warning accuracy. Freezing temperatures in the Great Basin, river flooding in the remote Cascades. The split-jet engine is perfectly engineering both. But the contradictions do not stop there. Look down at the deep south and the far southwest. The southern branch of this single circulation is ruthlessly driving dry, subsident air to fuel intense wildfires. We know that, but at the exact same time, it is leaving volatile, fractured edges of lingering moisture. Along these decaying frontal boundaries, the atmosphere remains just unstable enough to spark chaos. This is why the Storm Prediction Center is tracking isolated thunderstorms popping up across Florida, the Southwest, and even parts of Oregon. It is a marginal severe risk, a level 1 out of 5. There is no widespread tornado threat, but there is just enough energy left over from the trailing edge of the split-jet engine to trigger sudden isolated lightning and heavy downpours right on the fringes of the bone-dry burn zones. One single atmospheric wave is generating fires, floods, deep freezes, and localized thunderstorms all at once. Here is where it gets stranger. As if the continental stress was not enough, global monitoring systems are currently lighting up across multiple distinct disciplines. We are tracking a barrage of unrelated planetary and solar activity. Current space weather models are forecasting a 55% probability for minor R1 radio blackouts today. Recent M-class solar flares have subsided, but the solar wind remains highly elevated at roughly 536 km per second. Even though the overall geomagnetic field has returned to quiet levels with a KP index around 3, following an earlier Earth-directed coronal mass ejection, the baseline stress on high-frequency communications and GPS networks remains. Even minor solar events test our real-time space weather forecasting models. Down on the surface, the crust of the Earth is equally restless. In the Philippines, the Mayon volcano continues its persistent low-level strombolian bursts, emitting ash plumes into the night sky under Alert Level 2. Down in Indonesia, Mount Dukono just violently ejected an ash column rising 1,400 meters above its summit. And up in Kamchatka, Russia, the Krasheninnikov volcano is erupting for the very first time in approximately 600 years. This is a highly rare reactivation. It is likely linked to regional seismic unrest from a recent magnitude 7.4 earthquake, offering entirely new insights into magma recharge and tectonic interactions. It is a massive pile of global data. It forces emergency response systems and monitoring agencies into a state of heightened, multi-layered vigilance. But do not let the noise distract you. The solar anomalies and the stratovolcano eruptions raise the background monitoring stress, but they do not physically drive the weather story unfolding across the United States. They are completely decoupled from the tropospheric chaos over North America, so we must strip away the global static and return to the map. We have long-duration river floods in the Midwest, aggressive chaparral fires in the west, severe cold snaps in the mountains, and fractured severe thunderstorms down south. The real question becomes incredibly focused. Can the split jet engine alone fully resolve this impossible coincidence? It can. It absolutely can. The split jet engine is the only scientifically defensible unifier for this massive continental shift. When we step back and look at the thermodynamics of early spring, the pieces lock together flawlessly. This is the transition season. The atmosphere is violently trying to balance a still freezing polar region against a rapidly warming equator. To achieve that massive thermal balance, the upper-level winds simply cannot flow in a flat, predictable line from west to east. They must amplify. They must buckle. They branch apart and carve out a deeply entrenched trough and ridge pattern across the hemisphere. Think about what that actually means. You're standing beneath a fractured high-altitude river of air moving at hundreds of miles per hour. The sheer geometry of that flow dictates every extreme on the ground. When the northern branch of the split-jet engine digs deeply into a trough, it establishes a permanent locked corridor for low-pressure systems to ride. They follow the high-altitude steering currents like train cars on a rigid track. That is the exact mechanism behind the relentless long-duration watershed saturation. The continuous sequence of spring storms is forcibly guided into the exact same geography over and over again. The rivers fail because the atmospheric delivery system simply refuses to shift its aim. Just a few states away, the geometry inverts. The atmospheric wave peaks into a massive high-pressure ridge. Underneath that ridge, the internal dynamics of the split jet engine demand that the air sink. As it is driven downward toward the surface, it dramatically warms and compresses, practically obliterating the relative humidity. That is the deeply subsident side of the machine. It is the mechanical necessity of balancing the violent upward motion of the adjacent rainstorms. One sector of the continent must be ruthlessly baked dry so that the other sector can drown. The intense fire weather warnings and the rapid expansion of early-season burn areas are simply the localized physical expression of that sinking air mass. Here is the terrifying reality of this atmospheric setup. The split jet engine is not just creating static wet and dry zones. It is generating immense, continuous friction. The boundary lines where these drastically different air masses collide are inherently unstable. The dry subsident air aggressively grinds against the humid, rain-wrapped sectors. The polar air pulled down by the deepening troughs violently slams into the early spring heat. Those sharp, volatile interfaces are the precise breeding grounds for organized severe convection. The damaging wind profiles, the sudden storm alerts, and the scattered atmospheric instability are directly triggered by the immense shear forces embedded within this single circulation. Even the deepest anomalies on the map are resolved by the sheer scale of the system. The sudden plunges into freezing temperatures are nothing more than Arctic air temporarily spilling down the backside of the deep atmospheric troughs. The isolated river surges in remote mountainous terrain are driven by the swift, warm Pacific moisture riding directly up the front side of those very same troughs. The entire continent is trapped under a single, highly efficient thermodynamic engine. We looked at a map filled with seemingly disconnected localized catastrophes and naturally assumed chaos. We assumed broken weather systems failing in total isolation. We were entirely wrong. It was never a pile of unrelated extremes. It was never a bizarre planetary coincidence. It is one locked spring circulation. The split jet engine is taking the raw, chaotic thermal energy of a changing season and seamlessly channeling it into a perfectly orchestrated array of simultaneous extremes: the explosive fires, the widespread floods, the sudden cold snaps, the severe convection. They are all highly localized symptoms of one massive high-altitude machine. The extreme weather outside your window right now does not depend on random chance. It depends entirely on exactly where you happen to be standing beneath the wave.